Hello, I'm recording San Diego CPAPA's Meetup. This is meeting 78. I want to go over a few things to exercise, so let's go. Let's get going. So this is basically the agenda, the welcome, 3 CPP quiz. We'll talk about and filtering and containers, the modern style. And then we'll talk about std span, which is the safe buffer passing, and then we wrap it up. We'll do it quickly. The meeting is just me for today. So welcome to the 87. If you would like to speak anything in San Diego CPAPA's Meetup, please let me know. This is our Discord. I'll post the YouTube recording and any announcements in the quiz. Okay, so 3 questions for CPP quiz website. That's the first one. What would be the program? What would it print? So we have F, G, and H. If F is true, it's going to call G, otherwise H. So FHH, because we run F, it returns false. The tenor evaluates one branch. G never runs. H runs, and it prints H. And then return H, which is assigned to the result. And then it's printed again. So let's take a look. F is false, so we evaluating to H, which print H, and then another H. So FHH. This is a tricky one. Get future is called twice, which is not allowed. This is why we get an exception here. So get future and get future, it's going to get an exception, and we're going to print 2. Std promise may only hand one std future. The second get future throws a future error. This is why we get the exception. It prints 2. So it never the get is never runs actually. And then what this program print, it's kind of hard to get in first sight. So true of once you have type name of t and then t ... or you have type name of ... t and then t ... So let's take a look. It's A and B. So the first one is A. So 1 goes here, and then 1 and 2 goes to the multiple ones. Both of them compiles. There's no ambiguity here. True 1 is a single T version. It's most specialized. So it picks A. Right? The second one is 1 and 2. It's variadic pack version that match 2 args. This is why we have B. Okay, let's talk about filtering containers the modern way. Just a few exercises that I cherry picked from the overload journal from Yarnik. Problem: you have a container, you want to keep the elements that match a specific predicate. You want to return a new container. Basically, this is the signature. Sounds trivial. Standard library provides you at least 15 ways to write it. So we just exercise a few of them. Okay, so the classic one is CPAPA's 11, copy if plus a back inserter. It's pretty straightforward. You find a vector. Here we don't reserve anything. It's every back inserter might reallocate. We should when we review the code, we should know that. And when we review AI generated code, we should also understand that, especially if it's a critical path and we cannot allow that. So this is something that while we are reviewing more code than maybe writing code in the AI times, so we should be aware of that. So copy if the predicate holds, we use back inserter as an adapter, and basically it's pushed back on the output, and then we're returning out. Uh, hopefully, this would be aligned, the copy here to the return value. Works well, very simple. Erase if. Replace the old remove erase idiom with just one call. The trade-off is it copies the whole container up front, which is not the best approach, but it is one option. You make a full copy and then erase if the predicate doesn't hold. And then we have ranges algorithm. What I like in ranges that you don't need to have the begin and end. You have the container specified and then back inserter again. This is same idea as copy if, but it takes the container directly. There is no begin and end, which is pretty nice. This is C++20. If you don't have C++20, there is the ranges v3 that you can use. And then the most probably sophisticated one, it's the lazy view, which is views filter. So here's an example before we go into the actual main idea that we need to solve. So imagine you have a std vector of strings, and this is really nice the way the for loop is specified. You have s taken by const auto ref, and then std view filter. So you pipe vector with the std views filter, and this is the predicate. Everything that doesn't start with asterisk, and you get hello world error C++, which is really nice. So views filter produce no container at all. It's a kind of a lazy view over the original data. Nothing is copied until you actually iterate. It's a mental shift that ranges bring. And this is how we solve the main question with ranges. Take the vector, you filter B, and then we create a vector and return that. So that's one line, descriptive, no for loops. And once you get used to the way it's being written, you can compose a lot of these very easily. And I always point to the ranges v3 booklet that you can purchase online. I can have the link in the Discord channel for if someone is interested in that. Std generator is another way to filter. It's a coroutine based range. Elements are produced one at a time on demand. So take a look at this. If you're not familiar with std generator or coroutines, there is one session that I had maybe a couple of years ago on coroutines, which at least 2 hours long. You can take a look at that. But it's kind of a more advanced way. I wouldn't use this unless I really need that, but this is that coiled one at a time of the elements. Okay, use ranges for C++23, kind of the default choice. Introducing C++20. If you don't have 20 or 23, you can still use, or even if you have 20, you can still use ranges v3 if you're missing some of the functionality. Works with any container type, and it reads very naturally as you read the expression. If you stuck with C++17 or 20 and you cannot have ranges v3 even brought into your repository, copy if with back inserter. Just make sure that back inserter is like pushback, so it will reallocate if there is no more capacity. Erase if you don't mind copying first, which usually you do mind, unless there are some use cases where you want to copy first and something happens, you still have the copy untouched. Avoid the row, remove, erase idiom, no needed anymore. And this is the actual post that I cherry picked some of the examples. So take a look at that. Okay, span. This is one of my favorite ways to write safe buffer passing and kind of agnostic to the container that are you using. And again, in the area of using AI agents, this is something that you would like to keep in mind, either providing agents with guidelines, what to do in specific use cases, what not to do. And when you review code, which we mostly do probably in such environment where AI is writing most of the code, if not all, you wanna be aware of the opportunities to use StudeSpan. If you cannot have C++ 20, GSL or GSL Lite provides you span, which works very well. It's a header-only library that you can use. So I started with GSL span back at the times where it was pre-20, and then when we moved to 20, I converted everything to StudeSpan. So what's the problem? The problem is that in a lot of APIs, you see row pointer and length. Here's an example. This is something that you'll see often in the CPP core guidelines. There is a markdown file that specify a lot of core guidelines. This is one of them. So this is like a very good candidate of, I have a buffer that I don't own, and I would like to traverse or do something with that. In this case, it's a const pointer, and I have a length. So instead of having them separately in two different parameters, and you pass two different arguments to these parameters, as you can see here, it's not safe. It's confusing. It's error prone. And what if we could have something else, something that can adapt to a lot of contiguous arrays or contiguous memory, for example, studvector or studarray. Like you could use studvector and studarray, but it's not always possible for just passing a view, which is a pointer and length, which is used a lot in C++, in C, even for low level, not only in C, but C++ low level. So here's the studvector versus studarray. Each of them have their own merit. Vector is dynamically allocated. Array is just like the C array, but it's the same deal. It's aggregated, but with functionality like methods that you can use, and it behaves like a normal container. You could use template, but it's not the best approach. It's instantiate, in this case, two different types of this function, one with 512, one with 1024. Doesn't work well, basically because of the bloat. Span T, note the const int here, which is important. The const T here is important. You can have also const on the data if you don't want a data itself having any mutation. But the more important is the const T when you have what you're pointing to as const. So the nice part about that one is that I can pass C arrays, vectors, studarray, any contiguous memory that can be pointer and length, and StudeSpan has multiple constructors to handle that. This works well. GSL Lite, GSL, if you have C++ 20, if you deal with C++ 17 and below, so less than C++ 20, and it works well. Kind of the same idea. So StudeSpan has many constructors. There is dynamic extend and non-dynamic extend. From CRA, deduce the compile time. So studvector is taken from vector size. So it's kind of dynamic extend. Studarray, part of the array type, so it can use it. It's basically like CRA. From raw pointers, you can construct a span, like you have a curly braces p, 17, and basically you specify it explicitly if you don't have any choice. Once the constructed, the function doesn't need to know about the length, or it just deal with the StudeSpan as a simple container, and that's it. So it's safer than dealing with pointer and length. But there's a caveat to that. Just like every view, string view, and span and other views, don't store the span as a class data member because there is a risk of dangling pointers. So unless you know 100% that this is not going to be mutated, you should not do that. And in general, don't do that because it's confusing. If I see that, I always ask, is it safe? Like, is it like not going to be mutated? Like, think about stud vector that you initialize a class type with a member of stud span, and this vector is reallocating its memory because of a pushback. The span is not pointing to it's invalidating iterator, and stud span is a view to some memory, and the memory was reallocated. So it's dangling, so it's not safe. You cannot use it for lifetime management because it never extends lifetime. It's just a simple view, right? So unlike Rust, where you have this board checker that can check that you're not doing a mistake in this life management, we don't have that in C++. So it's a view, it's a contract where you pass something to a function. The contract is, this is not going to change, and I don't own it inside the function. And I probably don't want to keep I'm not going to cache the pointer and the length because it can change. You cannot point it to a non-contiguous memory, list, DQ, all of that. It's not going to work. It needs to be contiguous memory. There is no pushback. There is no container operations. But it's really working well with function parameters, contiguous memory that used to have a pointer and length. And you don't need to resize the data. You just need a view to that because you want to iterate, you need to count something, you need to do something from the data, but you don't own the data. So if you're working with AI, if you review AI code, if you look at legacy code or any code, and you see these pointer length pairs, this is a good opportunity that you should use stud span. It's not container, it's not owning, but it's a bound-aware view. Yeah, we already mentioned that. And there is a good paper here, which I took a few ideas from. That's it. It's gonna be. I said it's gonna be short for today. I just wanted to touch base with you. Thank you for showing, and see you next time.